If you're just joining us on this video, I'm so sorry that I forgot to hit record until just now. You only missed about 3 minutes of stuff. I is the square root of -1. If there's a negative in the square root, it pops out in the front. This is how we write complex numbers. A is real, the BI is the imaginary part. And then we add 6 plus negative square root of -4. The square root of 4 is a 2, and the negative just means we're going to have an I in our answer. Thank you for coming. Okay. All right, now we will continue. Please subscribe. Just kidding. My nephew, who's 5, he was watching something on YouTube the other day, and he's like, let's subscribe to this one. I was like, what are you doing? How do you know about this? I need to get you off of YouTube. Okay. It was just Dancing with the Stars videos. It wasn't anything bad. All right, so what we're going to do now is we're going to do operations with our complex numbers so we can add them, subtract them, multiply them, and also divide them. Adding and subtracting is what's most in common with what you've always done. Multiplying, it gets a little bit different just because of the powers of I. And then dividing is really essentially just simplifying our fractions, but we'll do our operations. If you're adding or subtracting, essentially we're just combining like terms. Real parts combined with real parts, imaginary parts combined with imaginary parts. So if I had 5 plus 3i plus -2 plus 6i, my real 5 and -2 combine to make 3. And 3i and 6i combine to make how many i's? 9i, thank you. I'll show you a subtraction problem as well. If somebody was going to miss one of these operation ones, it always ends up being the subtraction because they'll forget to distribute their negative at the end. So we have -3 minus 2i minus 4 minus 7i. So when you have a negative in front of the parentheses, it's going to have to be applied to everything after it. So really this ends up being -4 and then plus 7i. -4 and then that turns into a plus 7i. Nothing changes in the first set. So now we just combine like terms again. -3 and -4 make -7. And -2 plus 5 is, or -2 plus 7 is -5i. Thumbs up if we're good with this part. Okay. All right. The next thing will be our multiplying, but in order for us to multiply, we have to know that the powers of I will always simplify. Like if I was doing I to the 50th power, it simplifies down to either positive or negative I or positive or -1. Those are the only options for I powers. So when you're multiplying these, if you get something that's raised to a power, you need to realize that that needs to be replaced with one of our powers. If you see I to the first, we're just going to leave that as I for this. I to the second power is, anybody remember if you square I, what you get?
-1.
Because think about it, remember that I is the square root of -1. If you square it, Doesn't the square root sign go away? And you're just left with the -1 inside of there. So that's why I squared is -1. It just takes off the square root sign. I to the third. What about I to the third? How could we get I to the third? Anybody remember what that is? To get something to the third power, can you multiply the first and second power together? And did that get you the third power? Because 1 plus 2 makes 3. What's I times -1? -I. So I to the third is -I. And then I to the fourth power, it is just 1, right? Because you can square I squared, -1 times -1, and that makes 1. And after this, it just repeats. So then if you go I to the fifth, it's just going to be I. Sixth is -1. Seventh is -I. Eighth is 1. Ninth, 10th, 11th, 12th, 13, 14, 15, 16. So it just goes in a cycle like that. And the way that I remember this order, because I could generate it if I wanted to, just going through and saying, okay, that's that. Then I got to square it. Then I got to multiply those together. Then I got to square that each time. But I just remember, I say, I won, and negatives are in the middle. So like you're celebrating, like I won. And then negatives go in the middle. Alan, you didn't think that was a good trick? If I see you in the test going, I won, negatives in the middle, I'll say, you're welcome. All right. So let's see, before we go through some of the operations, just to figure out how to use this cycle and how to figure out what level or what row you would be on if you were doing powers of I in that regard. So let's just do a couple of these before we do some of our multiplying operations. If I had I to the 10th, it's going to be one of these four things. So we have to figure out which one we're going to be on. You can count if you want to, or we can think about like remainders and stuff. I'm seeing a lot of -1, right? Yeah, but we can count it, make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I to the 10th is -1. An easy way for you to think about this is you can think about the numbers on the top are our powers kind of like being remainders. If I divide 10 by 4, all right, 10 divided by 4, what's the remainder? How many are left over? 2, right? Because 4 goes into 10 2 times, and that gets you to 8, but then your remainder is 2 more. So this could also be thought of like that. What about I to the 31st?
Negative I.
It's -I, yep. So -I, that is on our third row, -I. Okay. All of the multiples of 4 are on the bottom row. So I always think, okay, 31 is really close to 32, which is a multiple of 4. This would be 32, so this would be 31. Or you can go 4, 8, 12, 16, 20, 24, 28, 28, okay, 29, 30, 31. Either way. All right. You kind of understand how you can use these 4 and they repeat in a cycle? Okay. Mostly the one that we use the most is I squared. That's -1, but we do see some of these frequently as well. All right, so now let's do some foiling examples. Some, by some I mean 1. Let's go -3 minus 2i times 4 minus 7i. When you see this, we just distribute as always. But if we end up with a power of I, we have to replace it with one of our numbers here. We don't want anything past the first power in our final answer. So we have negative 12 plus 21i minus 8i plus 14i squared, because there were two i's there. Okay. You can do this in one step if you want to in your head, or if you want to write it out again in another line, that's also fine. It doesn't bother me at all. But what is I squared the same as? I squared is -1. So anytime you see I squared, that's going to be changed into a -1. Okay. So when I think about this, this isn't plus 14. This is going to be 14 times -1, which is what? 14 times -1? -14, right? So we end up with -12. You want me to go ahead and simplify these? We can do that. Plus 13i minus 14. Which is -26 plus 13i. Okay, y'all okay doing the foiling, the distributing? All right, sorry about that. Now the next thing we're going to do is divide, which we really have to, we're not simplifying, we're rationalizing it, the denominator, the same thing we would do if we had to rationalize the denominator, but instead of having square roots, we have i's in the problem. So when you're dividing, you're going to multiply the top and bottom by the conjugate of the bottom. And I'll remind you what the conjugate is when we're working this problem. So we'll multiply the top and bottom by the conjugate of the bottom. You're normally not given the problems in parenthesis form like that, but I always put parentheses around them because I know I'm going to have to do some foiling. So it just kind of saves a little bit of time, and it makes you remember that you're going to have to multiply. So if I had 4 minus 2i divided by 3 minus 5i, I have to look at my denominator, which is 3 minus 5i, and I'm going to figure out what the conjugate is. And if you forgot, the conjugate just changes the sign of the I term. All right. So this was a -5i. Now it's going to become a +5i. We don't do anything with a real. It's just the I term is what we're going to change, the sign of that. So our conjugate is going to be 3 plus 5i, and we'll multiply that on the top and the bottom. We have to do the same thing on top and bottom so it doesn't change the value of our fraction that we have. And we just FOIL the top and also FOIL the bottom part. And simplify. So 3 times 4, y'all are probably already ahead of me. 3 times 5i, 20i, -2i times 3, -6i, and -2i times 5i is -10i squared. And do the bottom. 3 times 3 is 9, plus 15i, minus 15i, minus 25i squared. Remember your I squareds equal -1, so I'm just going to go ahead and jump down to the final answer here. I've got 12. This is going to end up being plus 10, won't it? 12 plus 10. So 12 plus 10 is 22. 20 minus 6 is plus 14i. Do we follow on the top? Any clarification needed? Okay. All right, and then the bottom part, what's going to happen to our middle I terms? They're going to cancel out. They're going to always cancel out when you do the conjugates together. That's the point of us doing this. So those will cancel out, and we've got 9 plus 25. 9 plus 25 is 34. It turned into a plus because it was a minus times a minus. Okay. Oh, I thought this was going to be the final answer. Oh, simplifying is gets you every time. What do all three of those have in them? They've all got a 2, so we have to simplify everything. So 11 plus 7i over 17. You're going to have a couple homework questions that ask you to just do a quadratic. They give you a quadratic and they say use the quadratic formula. I'm not going to do an example of that right here in the notes because we'll have to do one when we do synthetic division in like 3 examples. We're getting close to being done. But if you're doing that in your homework, the only difference between a regular quadratic formula and that is if there's a negative under the square root, you just pull an I out in the front. So when you finish and you have a negative under the square root, your I just comes to the very beginning. So if it says do the quadratic formula, just do it and you'll probably end up with a negative underneath your square root. But in your homework problems, they're going to come right after these dividing ones. They'll ask about that. Okay. All right. So now we're going to get on to where we're actually solving problems and solving polynomials, and they end up with I's in our answers. So this is the 3-6 part, but I think I only have 3 or 4 examples, so it's not that much. And most of them we can factor, and they're pretty quick. So if we're going to solve polynomials that have complex roots, we're solving them just like we tried before. We're going to try to factor them first. If they don't factor, then we'll try to find them in our answers in the calculator. And then we can also use synthetic division if we don't find all of our answers. But there are a couple important pieces of information. One of them we already know. The number of roots is going to be the degree of our polynomial. So we already got that. So that's one of our first important pieces of information. The degree equals the number of roots. And also that our complex roots or our irrational roots, they come in pairs. So the complex roots would be like if I had 5 plus I had to also have 5 minus I. So you've got to have a conjugate pairs for complex. So if you have one positive I term, you have to have the negative and vice versa. And you can also have it for irrational. Those are the ones that come from the quadratic formula. If I had 3 minus root 7, I'm going to also need what? 3 plus root 7, right? So anytime you have an I in your answer or a square root in your answer, you're going to have a partner friend. They need the positive and they need the negative. So you always want to try to factor first. We're going to have some that are difference of squares, and we'll also have some that are quartic trinomials, and those are the easier ones to factor. Those are the only kind of fourth power ones that I'll have you factor. So if they don't come in the form of these next two, then I would suggest just using the calculator to find the answers for at least the first one. All right, so here we go. So if you have x to the fourth minus 16, if your eyes are shut and you're laying on your pillow, I would suggest sitting up. Thank you. These are both perfect squares. 16 is a perfect square. X to the fourth is a perfect square. So we can factor them. Into x squared plus 4 and x squared minus 4. Does everybody agree that that is factored correctly for those? Okay. Are either of these a difference of squares and can be factored more? The first one or the second one? The second one. Yeah, you can't factor a plus square. You can do a minus. So we're going to just continue to keep this. So x squared minus 4 is x plus 2x minus 2. I can't factor it when there's a positive there. So how many answers are we looking for? We're looking for 4. We've spotted 2, so we know these are 2 of our answers, 2 and negative 2. We're down to a quadratic, so we could use the quadratic formula if we wanted to, but since it's just 2 terms, we don't really have to. So we'll take this factor, set it equal to 0, and solve it, and that will give us our remaining 2 answers. So x squared plus 4 equals 0. Coming from here, what would we do first? Subtract the 4. So x squared is negative 4. Then we take the square root of both sides. Or plus or minus the square root of negative 4. And what is the square root of negative 4? 2i. Thank you. And this equals plus or minus 2i. So if you were listing out all of your factors or all of your roots, all 4 of our roots are x equals 2i, negative 2i, negative 2, and 2.
Why couldn't we factor the x squared plus 4 like we did the x squared minus 4 again?
Because when it's a plus sign, it ends up being an imaginary answer. So we can't just do the real 2 answers.
Okay.
Yeah. Because if I had plus 2 and plus 2 to make a plus 4, you end up with a middle term if you were trying to FOIL that back. And we didn't want a middle term in there. Okay. All right, but if I wanted to write this all the way in factored form, super fun. You write it like normal, x minus 2i, x plus 2i, x plus 2, x minus 2. So technically it does factor, but there's imaginary answers in your factors. So here are your roots. This is your factored form. How many times does this graph actually cross the x-axis? 2 times. Imaginary answers aren't actually on our xy axis. Only the real answers are. So just know that this would touch the x-axis twice. Even though there are 4 roots, it doesn't mean it's going to touch it all 4 times. Okay. All right, one factoring, a different kind of factoring. So if you notice you have a problem that's got a 4th power, a 2nd power, and a constant, we're going to factor it like it was a quadratic. So what are our 2 things that multiply to x to the 4th? X squared. Then what multiplies to 8 and adds to 6? 4 and 2, thank you. And these are both going to be pluses. So since they weren't differences of squares, we set these both equal to 0 separately and solve them both. We just did the x squared plus 4, so that one shouldn't be too bad. So x squared plus 4 equals 0. X squared plus 2 equals 0. So subtract the 4 and then take the square root of both sides, just like we did before, and that's going to be plus or minus 2i for our answer on the 4 side. Now the 2 side, x squared equals negative 2 because I subtracted it. Take the square root. So x is plus or minus the square root of negative 2. Is 2 a perfect square? No, so it's got to stay inside of the square root, but the negative is going to pop out as an I. So our answer is going to be plus or minus I root 2. We don't leave the negative underneath the square root sign. So our 4 answers are here. Any questions on a problem like this one? I like these because you don't have to use the calculator and you don't have to do any synthetic division like the next one. So if you can't factor, you have to do like we did in 3-4, which is to go into your table or put it into y equals, go into your table, see when y equals 0, and then write that number down. So I'm not going to type this in the calculator. I'll just tell you what the answer would get from your calculator. So if you have x cubed minus 3x squared plus 3x minus 2, this is one that we can't factor. We could try to do grouping, but it wouldn't work. We can't use any of the methods that we just had. So you have to put it in your calculator to see if you can find all 3 of your roots. And if you can't, you'll use synthetic division. Okay. So in your calculator, you can see that one of your roots is x equals 2. So say we type that in, we get x equals 2. So did we find all of them in the calculator? No, you'll never find the imaginary ones in the calculator because they don't have i's in the table. So you'll only find the real parts. So we know that 2 is one of our answers. So what are we going to have to do to find the remaining 2 answers? Synthetic division. Yes, thank you. So put 2 in our box. 1, -3, 3, -2. Oh, I noticed on your synthetic division homework that a lot of y'all missed the ones that had placeholders. So make sure you pay attention that you've got one for each power. That was one of the most missed questions on 3-3. I had a lot of time yesterday to analyze all your work. So 1 and 2 and -1 and -2 and 1 and 2 and 0. That was kind of fun. So we write it as a quadratic, and now it's time to use the quadratic formula. Yeah, that doesn't factor. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I tried not to give you too many of these in your homework just because they take a while. So that's going to be 1 plus or minus, this is 1 minus 4, right? So -3 over 2. And this is what I was talking about. If you have a negative under your square root, we don't leave it in the answer in a quadratic. It just pops out as an I. And the very last thing, I promise, we've already done this, but we just didn't do it with i's or with square roots. So if they give you some of your roots and they want you to write your polynomial, you're going to do your parentheses like we did before and multiply them together. But it might not just be as straightforward as it was in the past. So I'm just going to show you how to set these up, and then you guys can work on, you can do the multiplying on your own if you want to practice it. So if they gave you that your zeros are, or your roots are 2 and 3i, that's 1 that we'll set up. And then what about if your roots are the square root of 7 and 2 plus I? So we're just going to do our parentheses for that. We have to understand that the I roots and the square roots come in pairs. So we have 2, 3i, and then root 7 and 2 plus I. In this first problem, which root did they neglect to write down because they understood that we knew it was going to have to be there? The other 3i, you have to have 3i and -3i. If you have an I, you have to have the negative part too. So we also need -3i. That's also got to be there. So when we make our sets of parentheses, how many sets of parentheses do we need? 3, because we're going to have 3 roots. So x minus 2, x minus 3i, and x plus 3i. When you multiply this, do the I ones together first because it makes it easier. And then you would multiply the last one. Then you multiply. And on this one here, we have root 7 and 2 plus I. Root 7 can't stand alone. It also needs a negative root 7. And if you have 2 plus I, you can't just have 2 plus I. You also have to have 2 minus I. Okay. So what looked like could just be 2 roots ends up being 4. So we need 4 sets of parentheses. X minus root 7, x plus root 7. And then x, and this is where it gets a little bit weird because we're going to have to subtract this whole thing. So x minus 2 plus I, and also x minus 2 minus I. I don't need that one. So when you're multiplying one like this together, do the root 7s first. Distribute that negative to both of those, and then do the I parts next. That's like a 3 by 3 when you're foiling it.